Welcome to Lecture 6 from Chapter 9 on chemical bonds. This section is going to be about naming compounds. So the thing is that some chemicals, some compounds you actually know from their common names. So you can see some of them here, things like club soda, baking soda, washing soda. And these names are based on their use or where they came from or some other sort of identifier. The problem is that uh, these names don't tell you much about the actual chemical. So sodium carbonate is called soda. The thing is, these three items all have soda in their name. However, they aren't actually made with the same chemical base. And so these names, these common names, aren't really helpful to us as far as telling us what's actually contained within these different sodas. So we now have modern compound names, and the thing is that there are millions of different combinations of the elements. And so we had to come up with a way to start naming all of them, since those common names give us very little information on the chemical composition. So there are two different sets of rules, a set of rules for naming ionic compounds and a set of rules for naming covalent compounds. And that's what we're going to be going through here in our next section. The thing is, for both types, for both ionic and covalent compounds, there is one common naming rule. And that is names ending with IDE. So IDE means a compound containing only two different elements. So, and that's actually mostly what we're going to be working with, unless we have a polyatomic ion. Those actually end in other things like ate, like carbonate. So if it ends in "ide," that means it only has two different elements. And for the most part, for what we're going to be working with in this class, we're going to be working with things that end in "ide," so just two element compounds. So things like, if you think about it, sodium chloride, sodium and chlorine. Carbon dioxide contains carbon and oxygen. So one of these, this one over here, we've seen this one when we talked about ionic compounds, ionic bonds. So this one's an ion. This one is a covalent bond. So you can see there's a little bit of a difference in how we put their names together, and so that's what we're going to be looking at. So we're going to start first, just like we did before with the bonds, we're going to start first with naming ionic compounds. So the name of an ionic compound is always going to be constructed the same way. So you're going to put the name of the metal ion first, the positive ion, and then the non-metal ion is going to go second, the negative ion. So the ion that comes from the left-hand side of the table is going to be the first part of the name. Then the ion from the right-hand side of the periodic table is going to go as the second part of the name. So think of something like calcium. Calcium is on the left-hand side, and that's the positive ion. And then chloride. That's from the right-hand side of the table, our nonmetal, so calcium chloride. And you can see it ends with "ide," so that tells us these are the only two elements that are in that compound. Now, transition elements, so those metals in the middle, like iron and so forth, remember they can have variable charges. So they can have different ion charges. They can be +2, +7, +6. And we used to put suffixes on these, so like ferric and ferrous, and that got really difficult to remember because one was for the higher, so if it was ferric for iron, that was the higher number charge, and ferrous was the lower number charge. We don't do that anymore. So you can see here, so +2, +3. Now we use Roman numerals, which is so much nicer because it tells us what the charge number is. So for example, if we have an iron +2 ion, it is iron 2. If it's a +3, it's iron 3. And that's how you write it in the actual name of the compound. So, So if we had, for example, iron oxide, it would be one of these two, iron 2 oxide or iron 3 oxide, depending on what we're looking at. In fact, I can tell you it would be iron 2 oxide because of the charges usually. So that's how we name ionic compounds. Pretty straightforward. We don't have to do anything fancy to identify the number of the atoms that are in the formula because you actually figure that out based on the charges. So you can just say the two things that are in it and put the "ide" on the end of the last one and you're done. Now, if you want to write up the compound formula for that ionic compound, there are a couple of rules. So you're going to write the same sort of order. So you're going to put the positive ion first, the metal first, followed by the symbol for the negative ion, so the non-metal second. So if we use our example that we've been using, well, we won't use sodium chloride because that won't help. So let's use, we'll use calcium because we know calcium is +2. And if we use, well, chloride, because I know this is a salt, we know chlorine is just -1. So we know the charges for these. So those are the symbols. And then what we're going to do is add the subscripts in order to indicate the numbers of ions we need to produce an electrically neutral compound. So remember that these guys have to cancel each other out. So, oh look, I actually read my own mind. I actually couldn't remember which one I used. So calcium chloride, we've got calcium chloride. So there we've got it written out nice and neatly. So Ca2, +2 and calcium -1. So then what we're going to do, if you remember from the earlier chapter, we're going to take this charge and make it a subscript. So this is the picture from your textbook. It's kind of confusing. That's what they're basically showing you. If you follow the little dotted arrows, this one is showing you to take the 2 and put it over here for the chlorine. And then they're showing you the same thing. They're telling you take the 1 and put it over here for the calcium. But we know that we don't need to write the 1 for the calcium because it's assumed that it's a 1. And so that ends up giving us calcium chloride, CaCl2, as our ionic compound formula. All right, so shouldn't be a surprise that we're going to have a little bit of a practice section. So first is going to be naming compounds. So I've got 2 here. So these both contain fluorine. So the first one I will do for you or help you out with, and then I want you to look up the second one and name that one. So the first one, Li, is lithium. So if you look for that one, it's in the first column of the periodic table. Here, if we flip over, I've got it. So lithium, it is the 3rd element on the periodic table, Li. And then fluorine, I just use this one a lot, so that's why I remember the F for fluorine. So this one right here, this compound would then be called lithium fluoride because it's an ionic compound. It's got just those 2 in it. And that's all you need to do as far as naming this compound. So lithium fluoride. So give this one a try on your own. Then the other thing is, what are formulas for some ionic compounds? So I've got a couple here. Oop, yeah. So we've got potassium bromide and copper 1 sulfide. So the first step for working on these is always to find the atomic symbols. So, and also then to find what the charges are. So if we take a look at our periodic table, again, I'll do the first one with you and then you can work on the second one. So we've got potassium. So potassium is right here, it's K, and it is in group 1. So that means that it's going to be a positive ion, because remember these guys over here, positive, they're metals. So it's going to be a +1 ion. And then we're looking for bromine, because it's an ide, so we're looking for the one that has no ide but is bro, so brome. So it's bromine, so that's Br, and it is over here in group 7. Since it's on this side of the table, that means it's a negative ion, and so it is a -1 ion. Since it's in this column, since it's got 7, that means it has 7 valence electrons. It's missing 1. So this one then would be potassium and bromine. And they both have, this one has a +1, this one is a -1. So we don't have to do anything to change it. It would just be KBr. Okay, so go ahead and give copper 1 sulfide a try. I will make sure that the answers for these are in the notes section of the PowerPoint. So the last section on ionic compound formulas is with polyatomic ions. So with polyatomic ions, you can build these formulas just the same way. So here we've got magnesium, and this is hydroxide. Again, if you need these, I will give you the table of the polyatomic ions. I'm not going to ask you to memorize their names or their formulas, but they are going to work the same way. This whole unit works as an ion with this charge. So how would this work? Well, we've got our magnesium, we've got our hydroxide, and so we're going to drop the charges. So we're going to take this and we're going to move it over here. Do the same thing for the 1. We'd move the 1 right here. You can see there's that picture from your book, and this is what you get. Now, for this formula, since it's a polyatomic ion, if the number after the polyatomic ion is not a 1, if it's a 2, 3, and so on, you have to put parentheses around that ion because that indicates that this is actually acting as an ion. And you'll see that in polyatomic ion compounds. So yeah, those parentheses indicate the subscript for the is for the polyatomic ion. So it wouldn't just be for the hydrogen, it's actually for the hydrogen and the oxygen. So this is saying that there's both 2 oxygens and 2 hydrogens in this formula. It wouldn't be put on there, the parentheses, if there's only 1. So you can see this is also a hydroxide ion, but because sodium is a +1, it would be 1 and 1, so no parentheses because it's assumed as a 1. So let's take a little bit of a practice on these. So again, not asking for the names, I'm just asking you to work on the formulas. So you're going to look up what we just saw, that potassium, this one is +1. So when you write this one out, it would be potassium, manganese, oxygen 4. Because these 2 will cancel each other out and you don't need to add any more. So here are the other ones to give a try, and we'll pick up with covalent compounds in the next video.